Good morning, everyone, and we're about a minute after 11 here, so we'll go ahead and get started. Thanks for joining us this morning. We'd like to welcome you from Cloudian and PDS to the webinar Simplifying Data Storage Management in a Multi-Cloud World. And I'd like to introduce our presenter, John Torr from Cloudian. John?
Hey, thank you very much. Am I coming through loud and clear?
Yeah, you sound great.
Excellent. All right, thank you. Well, thank you guys for joining. We got a quick half-hour webcast today to talk about a really interesting topic, which is how do you deal with data storage in the multi-cloud world? You know, the multi-cloud world presents a new set of challenges because it is new. The whole concept of multi-cloud is not something that has been in the IT landscape for very long, and so we're going to talk a little bit about where this idea came from and the kind of challenges it presents, and new technologies that can help us deal with these challenges. So let's just start off with the kind of the basics, just to level set. I mean, what is this multi-cloud thing? I mean, it's different from what we're used to, and I think that's the key point. It's different from the world we've been in. It used to be very simple, right? We had a data center and we had the cloud, and they were really different things. They were operated by different people. They ran different applications, very different workloads, and this made it very simple because there really was no need for interoperability between these two environments. They operated as separate things. That has really changed. Now people are now integrating the cloud much more into the enterprise landscape as part of our normal IT workflow. And I think some recent data from IDC really illustrates this point. This was a survey that came out just in September, where IDC talked to about 400 IT managers about their ideal state and how they would use the cloud in that ideal state. And what's interesting about this survey is the variety. The number of different ways that people are using the cloud. It's not just using Amazon or using Google or using Azure as your compute environment. That's kind of what we think of when you think of using public cloud, but in reality that's relatively in the minority. About 80% of use cases are actually a mix of different kinds of environments. So using one of those traditional public clouds in conjunction with an on-prem data center, or in conjunction with some other kind of hosted cloud where you got a third-party provider, or perhaps running a private cloud in a colo somewhere. So many IT managers are really viewing the public cloud as yet another resource in the IT toolkit, as opposed to being a completely new model that you just have to move to and change the way you're doing everything. In fact, they're using the public cloud very much as just another part of the IT landscape. And in fact, what we're seeing is these two worlds, the public cloud and the various forms of private cloud or on-prem, these two worlds, there's a lot of fluid movement between them. Another thing that IDC found in the survey was that about half of the apps that are currently running in the public cloud, IT managers are looking at relocating into some other kind of cloud environment, whether it be an on-prem private cloud, a hosted private cloud in a colo. About half of the apps currently running in public cloud, people are looking at moving. Now, this isn't to say the public cloud is by any means diminishing. Of course, it will continue to grow. What it says, though, is that the world is fluid, right? As their workload needs evolve, as apps grow, or as workloads shift, the app may shift. It may run in a different environment. We see this all the time. Things that run in a desktop 1 year might run in a cloud environment the next year. We've seen numerous examples of that kind of movement happening. And in fact, what we're seeing now is that the reverse movement is happening as well. So you would expect this. Now, the reason for this, why are things moving? Maybe the reasons that would probably come to your mind as well as kind of being top of mind concerns. Security. We all know that public cloud is subject to potential data breaches if things get misconfigured. It's putting a lot of trust in the user to configure things correctly every time. Hey, we can eliminate that problem just by running the app somewhere else. performance, if your data is far away or subject to a link, high-speed link between yourself and that data, you may be suffering performance concerns. And then cost. We all have heard about horror stories of people getting their first bill from the public cloud provider, and they just didn't realize it was going to cost so much because, in fact, the costs are not known until you actually get to the end of the month and you see what your workload looks like. Access charges are a very real thing. And then finally, control and shadow IT, two very related things. If you want to know exactly where your app is running and exactly what your users are doing, giving them free rein to go deploy things in the public cloud, may not give you peace of mind. So, all of these just point to reasons why, the public cloud and various other types of clouds are becoming a fluid environment. Now, what this means, though, is that, it makes a lot of complexity for the IT manager, right? Because now you've got different ways of deploying things. There's private clouds in that first category where you're replicating between two environments to do something like DR, for example, replicating from one private cloud to another for disaster recovery. Very simple. But then you can do that same thing going between on-prem and public cloud. And that, again, is pretty straightforward, but, you're going to have concerns about how these two environments are working together. And then finally, the multiple public cloud environment where you're trying to bring together a bunch of different environments that may or may not talk to each other. If you're using multiple public clouds at the same time, is GCP going to talk to AWS? Is it going to talk to the hosted cloud that you have on a remote site? And is that going to talk to the cloud in your data center? So, all these things really need to work together to make things operate seamlessly, which, in a space would be pretty straightforward if only they all spoke the same language. But, when you're trying to make things in IT work together, of course, that's always the concern, right? Do things speak the same language? And, in fact, the storage types that are used in most data centers, speak SMB and NFS. Those are the storage protocols of Windows and Linux. The cloud, on the other hand, if you look at AWS, which is obviously the most common, it speaks the S3 API. Those are two very different languages. SMB, NFS versus S3 API are not the same thing. So it does create interoperability concerns. And then the question is, well, how do I work around that to make things operate smoothly? Well, consider our goal, right? Where do we want to get? We want to get to an environment where you've got a common language and a common management framework, so you can manage all these things the same way. If I could just manage all these different environments the same way, using the same language, the same toolkits, gosh, wouldn't that be great? So that's not really, with traditional storage, that's not really possible, which has led to, the creation of various types of gateways and middleware to act as a go-between in these environments. Now, as you as IT professionals know, gateways and middleware have their own challenges, right? Because they connect together two things, and then, you've now got that gateway or middleware locked in between those two things. And that gives you a third thing to manage. Also a third thing to cause reliability or interoperability concerns. When you're trying to manage in between 5 things, that gateway or middleware becomes really impossible, because now you're having to do multiple variations of that gateway and middleware in between each of those pairs. And that creates a much higher level of complexity. So gateways and middleware really aren't the ideal solution. They're fine in a pinch, but what you really want is everything just to talk the same language. Can't we all just get along? So, that's where the world of on-prem object storage really came from. Why do you need this thing that the Cloudian does and others do in the marketplace of object storage that runs in the data center? The reason this exists is it is a common storage type with the cloud. So it does fulfill that goal of having the on-prem and cloud operate the same way, speak the same language, and be managed by the same tool sets. So this thing, on-prem object storage, fulfills that goal of achieving unification and simplicity. And they both speak a language that's we call the S3 API. Just a little quick clarification. I think this is a point of confusion often, and that is that the Amazon cloud, which is called S3, the Simple Storage Service, you probably know, but if you don't, I'll just lay it out. It speaks a language, a protocol called S3. That's somewhat inconvenient because the two get often confused. But the S3 language has become a de facto standard of cloud connectivity and is a different thing than the storage service itself. So the Cloudian product speaks the S3 API, as do other object storage products as well, but it's not the same thing as the S3 storage service. So S3 is one big reason for having an object storage platform. It's the same storage type as you find in the cloud. They're managed the same way. They use the same concepts, such as the concept of buckets for holding data as opposed to file folders. And they speak the same language, the S3 API. But what this means is it has a much larger implication, and that is that cloud integration is effectively built in to this environment because it speaks the same language, because it uses the same underlying storage model of objects and buckets. It becomes a very simple way of connecting environments together. So it becomes a very simple means of combining cloud and on-prem. Now, there's other attributes of this storage type that also make it very useful for that kind of collaboration. And I'll name three of them right here. And the first of them is scale. So why did this storage type exist to begin with? Maybe go back a few years. You don't have to go back all that far, just 10 years or 12 years. S3 didn't really even exist. So why does this new storage type exist at all? Well, it got started, or it grew, I should say, it took off because the cloud providers realized they needed an environment that could scale. They needed to be able to grow indefinitely in order to accommodate, the millions and millions of users they were accommodating. So if you go back in time, the last major cloud provider that was not built on S3, or I should say on object storage, the last cloud provider that was not built on object storage was Yahoo. Every major cloud provider since then has been built on object storage, and that includes Amazon, Microsoft, and Google. So the fundamental reason for this was scale. They needed something that would grow, and in fact, that's what object storage provides: is limitless scale and the ability to grow across multiple environments in a single namespace. It's also easy to add capacity because it's a shared nothing environment where every node operates in conjunction with every other node. So when you need more capacity or more bandwidth, you simply add another node on, and you've got more capability. So a very different scaling model than traditional storage. So this was the first thing, was creating enterprise exabyte scalability. Second thing was integrating search. Well, who was behind all this back in the old days? It was Amazon, Microsoft, Google. Obviously, search was a big part of their requirement. So metadata was built into this to create the ability to search. So each object includes data about the data to facilitate simple search. And in fact, that's true of on-prem object storage as well. You can use Elasticsearch and create essentially a Google in your data center. You can create a Google-like environment where you can search all of your data, as opposed to having to go from device to device to device and hopefully you find what you're looking for. It becomes a much more deterministic thing because everything is operating in the same namespace. And then the third thing was integrated data protection. So these cloud providers, they needed to protect their data, but it really wasn't practical for them to do a traditional backup. They just could not backup to tape the way an enterprise could, because they're dealing with so much data, it's growing so fast, that they had to have data protection built in and to be part of the model, not an add-on. And in fact, that's exactly what object storage does. So you've achieved these three things. You've got scalability, you've got search capability, and you've got integrated data protection, all built into the storage environment out of the box, right? So it's just part of what the architecture does. And all three of these were motivated by what the cloud providers needed, but the good news is all three of these things are very useful in enterprise data centers as well. They fulfill a real benefit to what you can do. The other thing, of course, is when they're in your enterprise data center, you've now got something that integrates with the cloud, because they speak the same language and they're managed the same way. And in fact, what I've got here is a screenshot. So on the left, you're looking at a screenshot of our product where you've got buckets, which are file folders, and if you look at those buckets, those are actually the top one is from AWS, so that is a bucket which exists in Amazon, but it's showing up in our UI. The next one below that is Azure, so that is a bucket that exists in Azure, but again, it's showing up in our UI. And then there's another one below that for Google. Again, that exists in Google, but it's on our UI. Why does that matter? Well, because now you can manage those three environments from a single place. Instead of having, your Azure account, your Google account, and your Microsoft account all separate, and you have to search them separately, and where did that data go? How are you going to find it? Now they're all existing in one place. You can search them all from one location. You can manage them all from one location. And in fact, they're showing up in our UI just exactly the same way they would show up in the AWS UI or the Google UI. So it's a very convenient way of bringing things together. A simple example, right, just showing data from a couple different environments in one UI, but very powerful when you think about the larger implications of finding and managing data. So, what is this S3 API and why does it matter? Well, the S3 API matters because it was the only API that was born, created, revolutionized in the time of the Internet. So if you look at this timeline here, if you go back to 1984, that's when NFS was created. The Internet didn't even exist in any real way. SMB was created in 1990. Again, the Internet was still, very, very much in its infancy. It was really 1993 when the Internet started taking off, and the S3 API was created around 2007, 2006. So it was in response to this need, this growing need for different kind of storage connectivity. And if you just look at a very simple example, here we're going to give you one example of what the S3 API does differently than traditional storage types. So one thing that they had to solve in the cloud environment was large file transfers over long distances. Obviously, this was designed to always operate over long distances. Anyone who's moved large files over, with the standard NFS or SMB protocol knows that, if you're trying to move, a gigabyte file over a WAN connection or something else that's uncertain, it can be problematic because interruptions during that transfer can cause the transfer to fail, and you may have to start all over again. S3 doesn't work that way. S3 breaks those large transfers down into small chunks, and if you lose part of the transmission, you only have to start that one chunk over again. So it's a very simple example of how that one feature, which is called multi-part upload, makes things like Netflix possible, right? Because now you don't have to transfer the whole movie to your viewing device at one time. You can move it in chunks, and if one part of that transfer fails, you only have to start that one part over again. So storage protocol born on the Internet, was really a game changer. So how does this help you, right, as the IT manager? So let me just give you a few quick examples about, in real live use cases, how this makes a difference to you. Well, a very simple example is just storage services, because one thing people want to do is provide a storage service to their users But you do it in the same way that they would get it from a public cloud provider. And in fact, we can do that. Right? We can provide a storage service which looks exactly like the storage service from a major public cloud provider, together with quality of service controls, billing, multi-tenancy. You can provide all that from this storage cluster. So you can, just by putting this thing in your data center, you've automatically got something which looks and acts just like a popular cloud service. Another really simple use case for this is data protection, because all of the data protection providers, Rubrik, Veeam, Commvault, Veritas, now offer S3 connectivity built in to their solutions. The last one to announce this is Veeam. They're already shipping it in beta, and they're announcing it publicly to the world in another week. Everyone now has S3 connectivity built into their solution, which means you've got a way to connect to S3 storage in your data center, which gives you a very cost-effective, scalable on-prem repository for backup data. You can also replicate that same solution to the public cloud for DR. So now you've got a very simple way of getting a backup target in your data center that can be automatically replicated to the public cloud. No middleware, no additional software, no additional features to buy, nothing else to license. You just hook it up to point it to the public cloud and say, replicate my storage there, and now you've got something which is off-prem for DR, and can be very cost-effective because you can put it on the lowest cost storage, and essentially you're never going to touch it unless you have a disaster. So you can put it on Glacier, never touch it, keeps the cost way down. Second, third example is in media and entertainment. Now this is a little bit of a complex workflow here, so I'm not going to go through the bits and bytes of this, but suffice it to say, each one of these steps in this process I'm showing here on this slide had storage associated with it separately. So they're moving from storage environment to storage environment to storage environment. This is the television production company that brings us programs like Frontline, Nova, Antique Roadshow. They're producing 6 different programs through this workflow that involved a lot of different steps. The challenge with it is it was slow. Getting data from step to step to step meant that by the time it got into their archive environment, it was at least 3 months. And that was the first time it was ever protected off-site. So during that entire 3 months, they were exposed. And in fact, because the process was slow, many people didn't even use it at all, which meant that a lot of the content, except for the finished programming, a lot of the content never got protected at all. What they moved over to was something that involved an on-prem private cloud that became a central repository for everything that went on in the workflow. So now when the data was ingested, it got put into that on-prem private cloud immediately. And at that point, it was protected because of that environment that had the redundancy built in. And it could be easily migrated or replicated to other clouds. So they're using Glacier for DR. They're using S3 for add-on capacity. They're using another public cloud called Sony C, which was used for content distribution. So the fact that S3 was built into that repository in their data center made it really easy to then share that data out with other clouds for different kinds of purposes. A very simple example of how the power of the multi-cloud completely revolutionized their workflow. With this private cloud on-prem plus the different clouds out in the public world, they were able to revolutionize this workflow. A last example is just the concept of doing data analysis in the cloud. The cloud has got an amazing array of tools that can be used for different kinds of analysis. And in fact, one thing people are very interested in is how do I use my on-prem storage for my repository, but then use the public cloud for that amazing capacity to analyze data. And you've got a lot of compute, you've got thousands of tools out there. How do I leverage this? And in fact, you can combine the public cloud and private cloud into a single environment, which then make it possible to store your data on-prem, analyze it off-prem, minimize the amount of data you're moving back and forth because you're only moving out the data you're analyzing as opposed to moving out everything. You never have to bring it back because you've already got it. You only have to bring back the metadata, the results of the analysis. So it keeps the access charges way down. The very simple way of bringing together public and private cloud to solve an operational problem and optimize how these two environments work together. So that's a quick little tour of how these two things work together, the public cloud and the private cloud. And in fact, when I say private cloud, it's as simple as the box on this picture. It's an appliance that goes in your data center, just like a NetApp device or an EMC device. It sits in your data center. It scales just as easily as adding one appliance onto another. And these things all work together as one to form this private cloud environment, which can then be scaled to an exabyte of capacity and can be seamlessly integrated with any of the public clouds out there, seamlessly integrated with Amazon, seamlessly integrated with Azure, seamlessly integrated with Google, and best of all, it works seamlessly with the things you are already running in your data center, such as Rubrik and Veeam and Pure and Commvault and Quantum and a whole host of other data management applications that work in your data center that you use every day. So that's kind of a quick little round-robin whirlwind tour of S3 storage in your data center. And with that, I'm going to turn it back over to PDS to put a bow on this.
Thanks, John. It's all great information. Thanks a lot. So on behalf of PDS and our partners here at Cloudian, I'd like to thank you guys all for joining us this morning. Now, we'd ask and invite you to continue this conversation about how PDS and Cloudian can help simplify data storage in your environment. So please follow up with us, and to set up a time to talk with one of our solution architects or the experts at Cloudian, please contact your account rep or use the contact information that you see here on the screen to get a hold of us. And in addition, the kind people over at Cloudian have offered up a nice little incentive. And anyone on this call that joins us for a follow-up conversation will get a $25 gift card. So we look forward to hearing from you soon. And with that, I want to thank you again for joining us, and we hope you have a great rest of the day. Thank you.
Thank you. Right. Bye-bye.